Hey, welcome to the next channel. So often whenever I get students to my home, one thing they notice is my off-grid solar panel setup. It is not essentially solar panel. In future I can set up anything like wind power or something like that. It's just I'm doing a sort of modularized setup as a part of my home lab. There are multiple objectives for the same. The reason is I'm also experimenting from past 3-4 years on CubeSats and also remote networking devices, self-sustained networking devices and off-grid networking devices in parts like Brazil and other such places. It can be even parts of UAE and stuff like that. So in these kind of remote places, what I'm looking for is to build a sort of an entire self-sustaining network topology, so that it doesn't need any external resources, especially something like power or something like that. The other thing, if you think about the network part, you can of course have some kind of wireless connectivity. The problem is, what about the power installation for the same? So sometimes you may not have any utility poles nearby, so in that case you need some kind of off-grid system like this. So since it's a rental property, I just lay down things as it is. I never installed anything permanently, so it may look sort of dirty, but it is very much essential. It is almost, I have done like a lab. And the other objective is, sometimes if there is no power or some kind of issue in terms of, they do also regular maintenance. Sometimes they chop down trees in Bangalore. See, these days it is raining quite heavily. It is the same situation in US as well as we have seen the flooding and hurricanes in Puerto Rico and stuff like that. So such kind of situation, you need some kind of off-grid setup. You never know in which situation you need an emergency backup like this. Never to depend on utility companies. It's not a question of how much you generate and how much you earn through this. It's a question of convenience. It's a question of some kind of alternate backup source of electricity at your at your own place. So that's about it. So throughout the years I have built multiple stages this setup, and currently I have a specific way I have built the same. So what I did is, in order to explain easily, I have portrayed the same in this Google drawing, as you can see here. So this is my entire lab setup. Let me just get this export of the same so that we can easily understand. So this is the same image I exported from Google Drawing, and I may publish it as a part of reference in my website, and also I'm going to share various links so that it may help you in terms of building your own setup. So as I said before, it's not a question about saving or generating power through off-grid or something, so that you can save utility power or things like that. Just definitely, if you think like a country like India, especially the domestic power is quite cheaper, you don't need to worry about saving, because essentially if you build any off-grid system, sometimes this is more expensive than utility power. So this is what it is. Anyway, so this is my setup. You can see here I have a huge 80 to 90 watt solar panel, and with which I have a couple of 10 or 20 watt panels. I'm not sure, because this is something I purchased almost a decade ago. I have paid a bit of premium price, and it's fine, because I also got someone sponsored for this experiment even at that point of time. So this is not something, the panels especially, is not something I have paid money out of my pocket. So this is a part of research, and it has been sponsored by a customer from Germany. So this is what it is. So what I have done is, I have linked all the positive nodes individually by these 3 amp diodes. These are generic 3 amp diodes, and you don't need to worry about, because you are not building any high sensitive electronics or some kind of audio equipment. It is just a power equipment, so it is fine as long as it delivers enough amount of amperage or current without getting heated up or something like that. So it can deliver up to 3 amp or 4 amps. I'm not sure, these are generic ones. Again, I bought these diodes almost a decade ago, still it works fine and it is perfect. So this is what it is. I have embedded within the panels, and then you have this negative terminals. All I connected in parallel, the negative ones and the positive ones are connected this way, so that till the diode it is individual. After the diode, all have been clubbed together, so that in case if one panel is in the shade, the other panel is in the sunlight, you don't need to worry about it. It will be a kind of combined output, it will be dumped across the terminals. So you have this positive and negative leads. So what I have done is, in order to make the diagram simpler, I just put a single line from here, so that it is easy to understand. This is like a flow or block diagram, whereas this is like a electrical circuit diagram. So from here, these two are connected parallel to this 1.5 farad capacitor. This is a car audio capacitor which I purchased in US. When I was in Arizona, I just ordered to my hotel room, so that I thought, let me later experiment when I go back to India. And I thought initially, actually I got this for my Jeep, but later it has never been used, and I thought, let me use it for this off-grid application. So you don't have to use a capacitor mandatorily, because this is also not so cheap. This is I believe I purchased it for around $50 or $20, so it is not that cheap. So if you are buying it for this purpose, it may be a costly expense, and instead of buying something like this, you can as well buy a super cap, and you can use it instead. You can connect it in series, so that it matches that 18 volts or something directly, whichever it comes out of the solar panels. So whichever way you can creatively you can connect the same. In my case, it is just lying around, and I have not spent anything for this purpose. It's just purchased it for something else, and since it is not getting used, I thought, let me connect the same. So from there, I connected to the power meter. This is a recently purchased power meter, which is a DC kilowatt meter. I purchased it in Banggood. You can see here, this is the power meter which I purchased. Since I need to measure directly in DC, I need to measure voltage and amps, and sometimes I can adjust the panels. I can just lift it and put it wherever there is sunlight. As I said, these are not permanently installed, so I can just put it wherever I have, and that's about it. So I can see live in the meter that how much there is the voltage corresponds to the sunlight, and also in case the batteries are charged, I can see the watts consumed will be near to zero. So in case if it is fully charged, then I can connect any laptop or tab or anything, and then I can just extract it out of the same. So that way I can use the same. So this is the power meter, you can see over here, and then followed by which you have this battery charge controller. So earlier I had a lead acid battery, as typical 7Ah lead acid battery. So for that I used something like this. So this is meant for lead acid batteries, whereas I can't use this for lithium ion. Currently whatever the batteries I am using is a lithium ion pack, which I have done by myself. I got this batteries salvaged out of my Acer laptop. It has some issue. The pack is having some issue, but the batteries inside are perfectly fine. It may not be in the tip-top condition, but you can use it for any off-grid installation like this. It just doesn't matter, because as far as the power comes in immediately, you can dump it inside any laptop or a tab or a power bank or something like that. So you should understand this is like this is like incoming water flow. You just need to take it to whichever container you want. That's about it. So I don't charge and keep these batteries much longer. I mean, it is not meant for storing electricity for longer periods of time. These are like buffer cells I'm using. These are like a couple of 18650s connected parallelly and then series, so that you have totally 6 batteries connected that way. So the total effective output voltage is around 11.1 volts. So I got this battery charge controller. I got it in eBay. You can see here, this is the charge controller I got. So this is a 11.1 volt 10 amp charge controller, which is very much sufficient. Unlike this one, this is meant for you can see the specs. If I see the specs, it is meant for a typical lead acid battery, which is 14.4 volt DC output, and you can connect up to 300 watt solar panel and stuff like that. So this is meant for DC lead acid batteries. So whereas this you can use it for lithium ion battery pack, something like this. So the power meter is connected to this battery pack. So the power meter have this sort of pin out. You can connect to the load to the battery pack charge controller. So in comes the solar panels, which is connected parallelly to this capacitor, and then the battery the power meter is not that reliable. What happens is sometimes the cumulative reading over here gets resetted once in a while. So by adding a capacitor, so far it is doing good. I just added this capacitor a week ago, not much before that. So with that, that issue is solved. This is the reason I don't like these kind of digital meters. Instead, if you have any those analog dials, what happens is it is just registered forever, and even without power, you can read the readings directly out of that dial. So this is anyway. It is now, for now it is fine. Maybe in future I may use it. Some kind of IoT connected power meter, so that I can remotely monitor and I can plot it as a graph in a database and stuff like that. So that's about it. So far it is fine. All I need to do is manually every month or every week I take the readings and then I maintain a record. So other than that, if you see here, so this is how it is connected. The output of this connected to the battery pack. And then from the battery pack I have tapped it to this UPS. So this is a small micro UPS which takes anywhere around 10 to 14 volts. This is also essentially meant for lead acid batteries, but it works perfectly fine with this lithium ion, because 11 volts is like a undercharged lead acid battery. So it thinks it's a lead acid battery. It just works fine as long as it gets the enough voltage and amps to feed that output 240 to 220 or 230 volt AC devices. So this is about it. So with that, this is done, and I have also done a tapping directly to this DC load. You can see here these battery charge controllers have this third pin. I think I can't able to zoom this picture. Yeah, this you can see here it has this load terminals. So with that you can directly connect it to any sort of load, DC load. So what I have done is I got this step down voltage power supply controller. With that you can convert approximately, you can see the specification. This I really got it in Amazon, so that's what I have depicted over here. Anywhere around 30 volts to 20 volts, you can convert it to any step down voltage. So this is I think it is called as a buck boost converter. In that it comes under I think buck converter or something. I'm not an electronics expert, so I'm not sure about the terminology. Anyway, it does the job. It gives that enough amperage, so with that you can tap a regular 5 volt and 3 amps and stuff like that. So I got this Nikon camera which I'm currently recording. Its battery charger is also got damaged or got defective when I was when I have taken it for some a trip. In the hotel room I was charging the same. Maybe there is a power surge or something, and its charger got faulty, and then I don't have any other option to build some kind of alternative for the same. So it is very much useful. You can convert it this outcoming voltage which is at the rate of 11.1 volts coming out of the battery pack through the charge controller output. And you can regulate with that potentiometer whatever they provide. So you can see here there are there is a pot, you have this, it's a sort of fine controlled pot, so you can have a very fine adjustment. I think it has some kind of pinion and rack sort of movement inside, so or else it is like a worm screw driven movement inside. So with many turns you can finally adjust the output voltage. You can even adjust up to the rate of 5.1 volt or 5.05 volts and things like that, so it is very good. So with that I have multiple modules. With that I can convert this 11.1 volt coming out of the battery to 5 volt, or in this case I need around 8.3 volts or around 8.5 volts for in this Nikon camera battery charger. So that way you can directly tap DC to DC, and this also reduces the energy losses in case if you use this UPS and then again you connect a regular charger, mobile charger like 5 volt charger or something like that to that UPS. So essentially what is happening, you are converting 11.1 volt DC to 220 or 240 volts AC, and then again it is stepping down that back to 5 volt DC. So this is huge amount of losses can incur. So in case if you use a micro UPS or anything like that, so instead you can directly use a DC to DC converter, a step down voltage power supply module. With that you can convert it to any voltage as the way you want. So this is my setup. What I can do is let me just take you guys to outside. It is quite cloudy today as it is raining consistently in Bangalore from past more than 1.5 to couple of months so far. So it's quite cloudy and the time is around 10 a.m. 10 a.m. at this point of time. Still it is outside, it is quite cloudy. So guys, as you can see, this is my setup. This is a huge 80 to 90 watt solar panel which I got, and then I got this couple of other panels as I discussed before. Since it's a rental property, I have not installed anywhere permanent. I can lay this panel over here, or sometimes in a sort of corner over here. So it all depends wherever it shines the light. And other than that, I got this sort of a lab which I set up near the door, because again, as it is a rental property, I don't want any sort of permanent fixture. So if you notice, you can see here these two wires which are coming out from the panels, and what I did is I fed them directly to this huge 1 farad capacitor. This I got it when I was in Arizona in US. I just ordered it online. So this is a regular, I think it is 1.5 farad. So it's a regular car, music player capacitor. So what happens is, earlier it is not installed. I recently installed the same. So with this, the advantage, what is the thing is, I have this power meter, as I explained in the system in the Google drawing. Before installing this capacitor, I used to connect directly the panels to this power meter, and you can see here it registers the amount of the total cumulative consumed power and other parameters. So you can also see the live feed of how much watts it is getting consumed. So currently it is not, anything is turned on, and outside it is quite shady, due to which it is not generating enough energy. And this thing is like covered. The reason is you should not have any sort of accidental shortening of this wire. So this is the reason I have covered with this wrap. I may do later by a more thicker wrap, so that it is never accidentally getting short circuited or something like that. So you can see here from there it is getting fed to this input, you have this diagram. So this I got it in Banggood. Let me try to focus the same. Yeah, you can see here it has this connection diagram. So this is how the input is fed over here, and then this is where it is getting connected to the load. So in the load, what I have done is I have connected to this charge controller, and this is a small custom lithium ion pack which I have done out of a faulty laptop battery pack. The batteries are fine, but the battery pack is not working. So what I did is I removed the same, and I made this battery pack. So essentially this is a 11 volt battery pack, because it has these three lithium ion batteries. These are those 18650s connected in parallel. So you have around 11 volts. I mean, they are two batteries connected in parallel with three batteries connected in series. So this looks like almost like a bomb. So it's just experimental. I initially never thought I will deploy something like this, but later I thought it's fine, and I'm just using these days for emergency purposes. So this capacitor is connected directly to the panels, and from there it is connected to this power watt meter, and from there it is connected to the input, which is represented as these solar panels. Let me just focus the camera. Yeah, you can see here it is connected to the charge, and from there it is connected directly to the batteries with these two cables. Since it's a very low power, it's okay to use something like this kind of cable to charge the batteries, because you don't exceed more than I think 60-70 watts, so which is fine. So there is also an output which is you can draw from out of these batteries. So from here what you can do is, so you have this let me focus the same. You have this lamp icon, which means you can connect any load to this charge controller. So what I did is I tapped this cable, and with this wire what I can do is I can connect any sort of makeshift voltage regulators like this. So this steps down the voltage. I have preset this from to step down any voltage like 6 to 30 volts down to 8.35 volts, so that with that pot set or potentiometer set, what I can do is I can charge this battery. I can charge this Nikon battery of this camera which I am recording, because this charge controller have got defective when I took it somewhere outskirts, and I just not sure, I think due to some sort of power fluctuation or something like that, it got defective, and later I just did the same. So this makeshift arrangement is more than enough. I have also connected a diode inside, so that it protects the charging of the battery, so that you don't have that reverse polarity or any sort of issues. So I have also done a custom makeshift charger like this. So with this, what happens is, again you can connect this barrel connector this way, and with this what happens is, as you can see, there are totally two voltage controllers are there. So with this you can tap around 5 volts and 2 amps out of these 2 USB ports. So this is my old almost a decade old PC which I salvaged, and then I did the same. So you can understand, this is not something like a setup which is intended for any practical use, but although I am using these days, this is mainly a sort of a lab which I have built, and then I started taking recently after I deployed this power meter, I started taking historical values out of the same. So with this I have also done is there is also another tap. This directly connects to the batteries. So you can see here, in this case I am using a higher gauge wire so that it can be connected to this micro UPS, and from this UPS you can tap 240 volts directly out of this. And sometimes you can also use this makeshift lamp which I have, as you can see, I have rigged out, and this you can connect it to 12 volts. So you can use this lamp for any sort of purposes. I can directly hope you can see. So I can directly tap from here and then I can connect to this lamp as well. So this way you can use this makeshift lamp. So you can see here it directly works. It is not anything like AC powered lamp. This I have done, I have converted to 12 volts out of a regular AC powered lamp. So AC 240 volts powered lamp. So with this it is done. So you can see here this is my battery. Inside also it has some capacitors and some more lithium ion battery packs. With that I have formed a sort of parallel circuit. So if you connect, it connects everything parallelly. Of course you should not do any reverse polarity, so I have marked with this tape to indicate the same. So with that thing done, anytime I can tap excess power, and then I have connected to this power strip. So of course it looks untidy, but it gets the job done in case if there is any power failures or due to the weather or something like that. Anyway I have this alternate power supply throughout the year. So you have this huge Xiaomi battery pack which I can charge. I have also my tab which I can charge. So this way I have set up a small lab. So the beauty of this is you can also make it modular. You can also upgrade anything as the way you want. You can also upgrade these batteries. You can upgrade it with higher capacity batteries. You can upgrade anything as the way as you go. So since it's a rental property, as I said earlier, I don't want any sort of permanent fixture. So I just built this way. Although it looks really untidy, it just works so robust, and it has been used for more than a year. And this is the reason I thought let me shoot a video and let me post. Maybe it may help you guys as well, so that you can salvage any old components and you can use it in this way. So as you seen outside, that is my setup. And that corresponds essentially to this diagram whatever I have depicted over here. So in case if you are building your own custom off-grid supply, you can take some clues out of this. You can do also some kind of mix and match of components. You can replace this battery pack. As I said, this is just a buffer battery pack. It is not meant to store energy for long periods of time. It is just I generally connect every day my tab or other devices, one or other device I generally connect over there instead of connecting directly to this utility power supply. Usually in India you get voltage surges and stuff like that. It is good to connect it via some UPS or some kind of surge protection device all the time. So this is what it is. So instead I can connect it over there, because these are about these are like very tiny power consuming devices. It doesn't need much power, so it is really ideal for some setup like that. So instead of connecting anywhere directly to my sockets, I connect it to that UPS and it just charges the same. So in case if you have any questions, or in case if you are looking out for any information, you can reach me via email, and I'm going to share all these links in the website, and I'm going to attach the link of my website in the YouTube description, so that from there you can directly hop on to my website and you can find all the links essentially wherever I'm pointing towards. I'm not suggesting you to buy any of these products, so I'm just sharing the information that this is how I have built. So based on your needs, in case if you want to produce more energy, you need to step down the same thing into much higher capacity or higher amp range devices. It can be a battery charge controller, it can be the power meter or anything like that. So you just need to just step down. So if you have a 200 watt or a 1000 watt solar panel array, So you just need to step down whatever I have done over here, or else you just need to buy a commercial off-grid solar installation kit. That's about it. So hope you guys loved watching this video. Thank you very much for watching this video. Have a nice day. Bye bye.